Hello everyone, myself Yadagiri, Assistant Professor, Department of EEE, MLR Institute of Technology, and also I am the faculty of BEE. In the last session, we have discussed about the analysis of the pure R network and also the pure integrated network and pure capacitor network. And after that, also we have discussed about the analysis of the RL series circuit, and after that, analysis of the RC series circuit, and after that, we have also discussed about the analysis of the RLC series circuits. So in this session, we are going to discuss about the simple numericals based on the RLC. I mean pure resistor network, pure capacitor network, pure inductor network. So for that, we need to take the problems on first resistor. I mean the problem we need to consider based on the pure resistor case. So the problem number one, the applied voltage of network is a 100 sin pi t is applied to the circuit containing a pure resistance of 20 ohms. So determine the maximum voltage value, or we can say amplitude value of voltage, and the second one is the frequency of the supply, and third one is the instantaneous current. So for that, we need to take the solution about this one. So for every numerical, theoretical kind of numerical, we need to take the given data. So for this, so the resistance of the network is given as 20 ohms. So this is the pure resistor network. So it is a 20 ohms offered by the resistance, and the supply is alternating voltage, that is a V equal to then 100 sin of 100 pi t, 100 sin of 100 pi t. So this is the applied voltage. So it has to drive some amount of instantaneous current because it's instantaneous voltage. And based on this one, so the applied voltage is a V equal to 100 sin 100 pi t, 100 pi t. So for this, we need to find out the first question, that is the maximum value of voltage. So maximum value means it's the amplitude or peak value of voltage. Maximum means the peak or amplitude value of voltage. So we know the value of RMS voltage. RMS VRMS equal to, it is a Vm by root 2. So this is the formula for RMS value of sinusoidal quantity. So here we have considered the instantaneous value of voltage, that is the standard value of instantaneous value of voltage is V equal to, so Vm sin omega t. So this one we need to compare with this one. So for that, the peak value of the network is 100 volts. So based on this one, need to find the peak value. Yeah, it's a peak value only. For this, we need to find the RMS voltage. RMS voltage not required because they have not asked. So only the question is asked about the peak or amplitude value. So this is the end of the first question actually. So it's a Vmax equal to 100 volts. So this much amount of peak value of voltage applied to the resistor. And question number 2. So question number 2 is the frequency of the supply. So the frequency of supply. So we know that we need to compare. So these two equations again. So for that, omega t equal to, so we need to write 100 phi t. Then omega equal to, so both the t gets cancelled means 100 phi. So we know the omega value, that is angular frequency, that is 2 pi f equal to 100 phi. And f we need to write means 100 phi upon 2 pi. So both are gets cancelled. F we will get as 50 hertz. So this is the frequency of the network is a 50 hertz. So this is the second question. So this question is asked. And the third question. So question number 3 is the instantaneous value of current. So the instantaneous value of voltage, so we have considered as a V equal to, so it is a 100 sin then 100 phi t. Then instantaneous value of current also, the standard value is, the standard notation is, so sin omega t actually it is. So Im we need to find, Im equal to according to Ohm's law, it is a Vm upon R, right? Then based on this one, Vm is a 100, then resistance of the network is given as 20, which means it is a 5 ampere. So the peak value of the network is a 5 ampere. So therefore Im equal to 5 ampere. Then need to find, so this frequency should be same only. So for that, then I equal to, the instantaneous value of current equal to, so it is a Imax means 5 into sin of 100 phi t. So this much amount of instantaneous current is circulating. So based on this one, so we need to also plot the waveform representation of voltage and current, so theta or omega t. So it's additional thing. We don't want to, they don't want to ask it. So it is additional thing. We need to plot the voltage and currents of the network. So this is the voltage. So it's a peak value is 100 volts. This value is we can say, so it's a pi, then 2 pi. So it is V equal to 100 sine of that is 100 phi t. So based on this one also we will get the current. So this value is a plus 5. I mean to say the I value is, we can write I equal to then 5 of sine then 100 phi t. So this is the end of the question. Asked about the peak value of or arbitrary value of voltage, then frequency of supply is 50 hertz, then instantaneous value of current is a this I equal to 5 sine 100 phi t. So this is the end of the first question based on R. So the problem number 2. So we would like to take the problem number 2 based on the pure inductor. So because it was R, then in second value is L. So need to take an inductance of the coil as a negligible resistance of the 0.1 Henry. It has to connect to 220 volt supply. 220 volts cover 50 hertz supply. So we want to find the current of the network and also the power, and as well as the voltage and current expression in terms of the instantaneous nature. So for every kind of theoretical, numerical, so we need to go through the given data. For that, need to write the given data first. So the foremost thing is mentioned, that is the inductance of the coil is capital L equal to 0.1 Henry, and the applied voltage always given as RMS. If it is mentioned like this one, means it is RMS voltage only. So 220 volts means VRMS. So VRMS, we know that for the sinusoidal waveform, so Vm by root 2. So this is about the RMS voltage. Next, the frequency of the supply is given as 50 hertz. It is a 50 hertz. So then based on this parameter, we need to find the first of all current and also the power, and as well as the sinusoidal expressions of the voltage and current. So very first one, so need to find the current of the network. So the formula is current I equal to V by XL, where XL is the inductive reactance. If I are able to get the current flowing through the network, so this is the pure inductor. Then so if you are able to find the current value of the inductor, so we need to find the XL offered by the inductor. This is the 0.1 Henry. Then for this, some amount of XL is there, so that we need to find. Then the XL equal to, there will be a formula of the XL. So we have already clearly determined about the XL equal to 2 pi FL in the case of pure inductor. So then we need to substitute, this is a 2 pi, then it is a 50, then inductance is a 0.1. So therefore XL of the coil should be 31.41 ohms we got. So this is the XL offered by the inductor coil. So it's not at the end of the first question. Then again still we are in the first question, means then IL equal to it is a peak value we need to consider. This is a 220 divided by the then 31.41. So 220 divided by the 31.41. So which means, so the ratio of these two parameters and these two values, we will get the 7 amperes, 7.01 something like that we'll get. Then the current flowing through the network is a 7 ampere. Is the first question. Then the second one, the power, average power. Power means average power. They have not asked about the instantaneous, means it's average power only. So the average power taken by the inductor should be equal to 0. So because over a complete cycle, the average power taken by the inductor, so with the sine function, sine or cosine function with the double frequency, should become 0. So based on that, P average value becomes 0 only, because we got Vm Im by 2 sine of 2 omega t. So based on that, the average power taken by the inductor over a complete cycle should be 0. So average power, so taken by inductor over a complete cycle, over a one cycle is 0. So based on that, P average should be 0. So this is the second question. Then third one is asked about the instantaneous values of voltage and current. That is a V equal to, question number 3. So V equal to Vm sine omega t, then I equal to Im, then sine of omega t, minus phi. So we don't know the exact angle. Actually, it is a inner means we know the angle, that is exactly 90 degrees, 5/2, or we can say. So we need to find the Vm value based on the Vrms. Then Vm equal to, so root 2 times of Vrms. So which means root 2 times of 220. So that is 311.12 we got. Then omega value equal to 2 pi f, which means 2 pi into 50. So there is a 314 we got. So therefore v equal to, small v equal to, so every instantaneous values we can mention in terms of small letters. So 311.12, then sine of, so 314t. So this is the instantaneous value of voltage. So need to find the instantaneous value of current. So then we will find the I max value or I peak value. I max or I amplitude equal to the, so Vm by XL. So we have already determined the formula of this one. So in the inductive reactance, that is in case of the pure inductor. So which means it is the 311.12 divided by the 31.41. So ratio of these two, we will get So we will get the Im value. So I max equal to, it is a 9.9 ampere we got. So the peak value of current in the network is a 9.9 ampere. So based on this one, I equal to instantaneous value of current equal to 9.9 into sine of 314t minus 5/2. So this is the instantaneous value of current. So this is the end of the question number 2. So they have asked about the current value. Then so we have done that value as a 7 ampere. Then asked about the average power, that is a P equal to 0 we got. Then the instantaneous value of voltage and current, these two. So now the problem number 3. So need to take the problem number 3 on capacitor. Oh, I think the problem number 3 purely depends on capacitor only. So that is the capacitor of the 100 microfarad is connected across a 230 volts, 50 hertz AC supply. So need to determine or find the reactance of the capacitor and RMS value of current and also the amplitude value of the current. So for that, so need to write the given data or go to the given data. So this is the given data. So in the given data, so they have mentioned like C value. First of all, C equal to 100 microfarad. They have mentioned clearly. Then the applied voltage in terms of RMS is the 230 volts. Then the frequency of the supply is given as 50 hertz. So for this mentioned data, need to go through these. Need to go through these parameters. We need to find these 3 parameters. So that is the very first one. So reactance of the capacitor, that is the formula is X to C or 1 by omega C. So we have completely discussed about the reactance of the capacitor plates. So that equal to 1 by 2 pi FC. 1 by 2 pi FC, which means 1 by 2 times of pi into 50 into then 100 into 10 power minus 6, because it's a microfarad. So that's why 10 power minus 6. So therefore the capacitance offered by the reactance offered by the capacitor plate should be after simplification of this one, it's a 1 by so we will get so 0.0314 will get after the simplification. It's a 31.84 ohms we got. Therefore the reactance offered by the capacitor plates is a 31.84 ohms. So this is the end of the first question in the question number 3. So next third question number 2. So it is the RMS value of current. RMS value. So we know the RMS value of alternating signal or sinusoidal waveform is it is a Im by root 2. So we are able to get the Im value from the reactance offered by the capacitor plates, that is a Vmax upon X to C. So Vmax also we don't know. So that Vmax equal to root 2 times of Vrms, because we know the Vrms value is a Vm by root 2 based on that. Then root 2 into 230 I think. Then with this value is a 325.2 volts we got. Therefore, I maximum equal to 325.2 divided by the 31.84 we got. So for this, the I max value and the peak value of current or the amplitude value of current, I max equal to, I max equal to, so it is 10.21 we got. It is a 10.21. So is it enough to get the I max? No, means we need to find actually the IRMS value. So based on this one, the IRMS equal to, what's IM value? It's a 10.21 divided by, root 2. Then based on this, so we will get the IRMS. So based on this, we will get the IRMS is a 7.22. 7.22 ampere. So this is the question number 2. Then go through the question number 3. What they have asked to find the amplitude value of current. So question number 3 is a amplitude value of current. Amplitude value means amplitude or peak value or the maximum value, all are same only. So for that, I max equal to, that is, so root 2 times of the IRMS. So just now we have determined the IRMS value, that is 7.22, I think. Yeah, it is a 7.22. Root 2 into 7.22 means I max equal to the 10.21 we got. So actually we have done it is already, means, so again this is the way to get the I max value. So this is the end of the third question. In the whole session we have discussed about the problems based on so pure resistance, so problem based on pure inductance, that is capital L, and also problem based on the pure capacitance. And these three we have till now discussed, and we are also going to discuss that is a problem based on RL series circuit and the RC series circuit, and after that RLC series circuit. So this is the end of the session. In the next session we are going to discuss about the simple numerical based on RL series circuit, RC series circuit, and as well as RLC series circuits. So thank you and all. Thanks for watching. So have a nice day.